Right, guys, today we have lesson 1.4, so you should have a classwork from the sub. If not, make sure that they do give it to you. It should be in the folder. And we're going to do this lesson. It's going to be broken up into a few different videos, so you have your classwork. You can follow along with notes, fast forward, rewind, whatever you need to. And we have a warm-up right here for you, so why don't you guys pause the video, go ahead and do this, and then resume it once you're done. All right, with number one here, if the whole radical, if the whole ratio or fractions underneath the radical, just make sure you look, right? 7 divided by 40, you can't reduce it, but a lot of times you can, and it saves you a little bit of a step here. Just to save time, I'm just going to rewrite this as, I'm going to say root 7 over 7, 7. Over 2 root 10, which is the same thing as root 40. And then from here, your final answer, you can multiply both sides, right? You don't have to multiply by 2 root 10 because the 2 is fine. It's not under a radical. It's not part of the problem. I'm just going to multiply by root 10 over root 10, and then your final answer would be root 70 over 20. And that would do it for this one. This one down here, hopefully you did it. There's kind of a lot of different radicals going on here. But just to give you the final answer, it's going to be 27 minus 3 root 11 plus 9 root 5, it looks like. Root 5, and then minus root 55. That's not really working. Hold on. And then that's all going to be over 70. It looks like it'd be 79 minus 81 minus 1. That's it. Can't simplify it. Don't do anything else with it. This is kind of an ugly final answer, but that's all you got. All right, so 1.4, right? We're actually going to be dealing with the imaginary numbers, which it's almost, I compare it to Stranger Things. If you've ever seen it, there's like this alternate dimension. Kind of the same thing with imaginary numbers. They're called imaginary, but they are used in the real world. But it's this whole other set of numbers that are apart from the real number, um, system. So we get them from quadratics, which I'll show you in a second. But essentially, like a lot of things in the real world, you use imaginary numbers. It's not an imaginary world, but you do need a separate set of numbers that can help you solve certain problems, right? So if I said solve x squared plus 1 equals 0, right? Kind of doesn't make sense, but if you were thinking about it, you could subtract 1 from both sides. You get x squared equals negative 1, and that's kind of where the problem is. How can a number be multiplied by itself and somehow equate to a negative number? It doesn't make sense, right? Even a negative number, once you square it, it becomes positive. So how could it ever be negative, right? But if you were going to go through the motions and do it, what you would do is, you'd take the square root of both sides. And whenever you take a square root, you always account for a positive and a negative. And once you take the square root of x squared, you get x, right? And you get x equals plus and minus the square root of negative 1, right? Which doesn't really make a lot of sense. But we call this number, square root of negative 1, we call it I, right? So the actual answer would be plus and minus I. And I just stands for imaginary. It means the square root of negative 1, right? So and that's where we get this whole other set of imaginary numbers, which is the reason why we call it the complex number system instead of just a real number system, because, complex can mean real or imaginary. And then every number that you've ever known can be written in this complex number form, which is just a plus bi form. So a and b are just numbers, but once you multiply a regular number times an imaginary number, that whole thing becomes imaginary. So like if you just think, well, what about the number 5, right? Well, the number would be 5, which is the same thing as 5 plus 0 I, right? We know it is 5. We're always going to know it is 5, but you can write it in this form, right? The number 7I would just be 0 plus 7I. And then as you'll see today, you're going to have numbers with both a real part and an imaginary part, like 2 minus 3I. right? That is just a complex number. Um, it has the imaginary part, so I guess the whole thing is imaginary, but you can write any number using a plus bi form. A and b are just regular numbers. I is imaginary. So when we get into i's, we're just going to do this. We'll go through this and hopefully it'll make some sense, right? So we know, I'm going to make a side note under here. We know that I is equal to the square root of -1, right? But if you're ever solving something on a test, instead of saying square root of -1, you would say I, right? So I squared would be I times I. So if you think about it, it's the square root of -1 times the square root of -1, right? So if you the answer is going to be -1, right? The square root of 3 times the square root of 3 is 3. The square root of 100 times the square root of 100 is 100. So when we have the square root of -1 times the square root of -1, it's just going to be -1. So I squared, and we might see that, that's just going to be equal to -1. I to the third, right? Just to write it out, it's the square root of -1 times the square root of -1 times the square root of -1. Whoops. Right, so these two, square root of -1 times square root of 1 is going to be -1. So times another square root, right? This is just going to be -1 times, and that's just I, right? I'm just going to write it as I. So -1 times I is -I, right? So you have two different answers you can get from square. I to the fourth, right? That would be if we wrote these out 4 times. Well, the square root of -1 times the square root of -1 would be -1. And then the square root of -1 times another square root of -1 would be -1. It would literally be -1 times -1, which would actually be +1, which is very interesting how we can end up with even a positive number from doing a whole bunch of i's. So I to the fourth is going to be just +1. You could think of it as I squared times I squared, since I to the fourth is the same thing as I squared, essentially squared, right? That's your exponent rule. You would multiply these two things together and you get 4, just a different way to write it, but you get 1. And those 4 answers, either I, -1, -I, or 1, those are going to be the answers for all of these problems, because the further and further you keep multiplying by an extra, square root of -1, you're going to end up having these exact same answers all over again, right? So I to the fifth, right? That's the same exact thing as I to the fourth times I to the first, right? That exponent rule is you actually add the exponents when you multiply the same bases. And we know, and the reason why I write it like this is because I to the fourth is equal to 1, right? So if I can ever write something as I to the fourth, I know that that part's just 1, and 1 times anything is just going to be whatever that anything is. So it's almost like I could just kind of like cross this off and say, all right, I'm really just dealing with I to the first, because I to the fourth is 1, right? So I don't have to worry about it. So I to the first, that's your answer. We don't write the 1 as an exponent, we just write I, but I is the same thing as I to the first, right? I to the sixth, I'm going to rewrite that as I to the fourth times I squared. And again, why do I do that? Well, because I know that I to the fourth is equal to 1. So I can essentially cross it off. And I know that my answer is going to be the same thing as what I squared is equal to, which was -1. So that's the answer, right? I to the seventh, I to the eighth, you guys can do those two on your own. Pause the video and then restart it once you're good. But you kind of get the hint. All right, so I to the seventh, the same thing as I to the fourth times I to the third. So the final answer is just going to be whatever I to the third equals. So that's -I. And I to the eighth is the same thing as I to the fourth times I to the fourth. Or you could write that as I to the fourth squared, right? Power raised to a power, you multiply here instead of adding here, the same thing. But basically the same thing. I to the fourth we know is 1, so 1 squared, or 1 times 1, we know that that's just going to equal 1. That's it, right? So if you notice, all of these answers are the exact same answers as these 4 were over here. Right? I to the 13th, you can keep counting in your head, but I'm going to say that's I to the fourth to the third power times I to the first. You might say, why did I do that? Well, 4 times 3 is 12, right? So I know that I to the fourth is 1, and then 1 to the third is obviously still 1. So that I can kind of basically get rid of this whole thing because it's 1, right? And so 4 times 3 is 12, plus 1 is 13. So the whole thing's equal to I to the 13th. So really, if that's 1, it's 1 times I, which is just I. Right? I to the 100, same thing, it's I to the fourth to the 25th, which is the same thing as 1 to the 25th, because this whole thing is equal to 1, and 1 to the anything power is just 1. Right? Basically, if a number here divides evenly by 4, then the answer is just going to be 1, because you could rewrite it as I to the 4th to the something. Now, 103 does not divide evenly by 4, but 100 does, right? So I know if I to the 100, and then I can multiply that by I to the third, right? Because 100 plus 3 is 103. And since I know that 100 divides evenly by 4, I know that the whole thing's just equal to 1. Right? So it's really just, because the final answer is going to be I to the third, which is negative I. Right? Same thing. 1038. It's I to the fourth to the something. I'm not super concerned with it. I know that 4 goes into 1000, right? 4 definitely goes into 1000, it goes into 100. So I'm going to say it's I to the 1000. And since 4 divides evenly by that, I can ignore it. And that leaves me with 38. So I know that 4 goes into 36, and that's smaller than 38, so I can use that. And then I know it's I squared, because 36 plus 2 is 38. So I to the 36, which also 4 goes into 36, that's equal to 1. So it's literally just going to be I squared, which is, negative 1. And that would be your final answer, okay? Now with negative numbers, we do the same game, but with negatives, you kind of get thrown off. You still try and pick a number that's less than it, right? So when I did 103, I looked at I to the 100, which is smaller than 103. I don't want to go to I to 104 and then go down to negative 1, because then I to the negative 1, it can be confusing. Same thing here. I went to 1036, and then I just figured out what was left. So when I do I to the negative 1, I want to think of a number that's smaller than negative 1, just like 100 is smaller than 103. So I'm going to do I to the negative 4. And then times, I don't know why I put that in parentheses, I to the third. Right? Now I to the negative 4 negative 4 divides evenly by 4. The same thing as, 1 to the negative 1. It's still going to be 1. So because this divides evenly by 4, I can cross out. It's equal to 1. So the final answer is I to the third, which is negative I. So I want you guys to kind of follow that logic and do these last 4, and then resume the video when you're done. All right, I to the negative 7th. I'm going to say I to the negative 8. This isn't working so well. Times I to the 1, because negative 8 plus 1 is negative 7. And because this divides even by 4, I'm just going to ignore it. So the final answer is just going to be I. Negative 100, easy, divides by 4, all by itself. So that answer is just going to be 1. Negative 101, don't use negative 100 because it's not smaller, right, than a negative 101. So I'm actually going to go I to the negative 104 times I to the third. And then because this one divides even by 4, it's 1, and you just get negative I. This one right here I did on purpose, but basically, negative 4 goes into negative a million. So, you don't have to write it out, but I'm going to. So I to the negative 1 million. And then what's left? 50. So, I'm just going to write I to the negative 50. And because this one divides evenly by 1, I'm just going to cross it off, this first part. So I got negative 50, right? I know that 4 will go into negative 52. And I want negative 52 because that's smaller than negative 50. And then so times I squared, And then, so because that divides evenly by 4, this one right here, I can cross that off. So it's just I squared, which is -1. And that would be your answer for that. So every answer you possibly get is going to be one of these four, either I itself, negative I, or 1 or -1, right? So we'll do a quick practice and then with just 2 examples, and then we'll get into the second video. So here's our first example, right? The question would be to simplify this. It doesn't say it, but the question would be to simplify the square root of -20, right? So, you know, we kind of know from doing the past couple lessons on radicals that the square root, right, of -20 can be broken up by its factors, right? So I'm going to say it's the same thing as the square root of -1 times the square root of 4, because 4 is a perfect square that goes into 20, and the square root of 5, right? If you multiplied all of these up, you would get -20. Now I always pull the -1 out, right? The square root of -1 is I. The square root of 4 is 2, and then square root of 5 is square root of 5. So that is how we write it. You know, that's how we write our final answer. It's 2I root 5. There's a reason why we don't put the 5 at the end. And I know I gave you earlier that thing that said A plus BI. So you might think that the I goes on at the very end. But we actually put it in front of a square root. And the reason is because we do not want the I to be confused as being underneath the square root, because then it would be like a square root of a square root of -1. We don't want to be confused. So we always stick the I out in front of a root if there is a root. But we do write it after the 2, you know, and that's kind of like closer to that, but you know, as good as we can get. And that's basically how we simplify. So on your own, I want you to do 5 root -56, pause the video, and then resume it when you're done. All right, so right here, I'm going to take out the square root of -1 with an I, and it really can just be as simple as that. So I have 5I root 56. And now it's just a matter of looking at the square root of 56 and figuring out what's perfect that goes into 56. And there is. 4 goes into 56. You know, this is going to be broken up into the square root of 4 and the square root of 14, I think. So square root of 4 is 2. So when we have 2 times 5, we get 10. So final answer is going to be 10I root 14. And that's it, right? So that's the end of the first video.